Hi everybody. I'd like to introduce you to another base, and this is called base 16. And in base 16 we write r equals 16, also known as hexadecimal, and we number 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15, and we give it a symbol. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and now we've run out of decimal symbols, so we start to borrow alphanumeric symbols: A, B, C, D, E, and F. And so now what we have is a direct lookup correspondence to binary, that's base 2. And what we write here needs 4 bits, so we write 4 binary 2 digits: 0001, 0010, 0011, 0100, 0101, 0110, 0111, 1000, 1001, 1010, 1011, and you can see the 9, the 10, the 11, 1100, 1101, 1110, and finally 1111. So now you can spell numbers. D, E, A, D. Base 16 must be equal to what value in base 10? Using positional notation, we can look up D, and we see it's a 13 times 16, because that's the new base, to the 0, 1, 2, 3, that's your position. Then there's E, E is 14, times 16 to the 2, plus A, which is 10, times 16 to the 1, plus D, which is 13, times 16 to the 0. If you write things out in this way on a test, it's correct. You don't have to simplify and you don't have to multiply it out. Or you can multiply it out and you can get a decimal value. Now suppose you wanted to take a number, DEAD, and convert it to binary. Well, you can do that by direct examination. D is 1101, E is 1110, A is 1010, and D is 1101. And that's your base 10 result. Now, if you want to, we can find out what that must be equal to in base 8. And we do that by grouping. So we group by 3s. And then use our table lookup: 5, 5, 2, 7, 5, 1. And now we can write it out in base 8. 1, 5, 7, 2, 5, 5. Base 8. So, to recap, if we're in radix equals 10, and we want to go to base 2, we use repeated division. To go back, we use positional notation. To go to base 8, we go by grouping. To go to base 16, we go by grouping, but we group by 4. To go from base 16, to go from base 16 to base 10, we use positional notation. To go from base 8 to base 10, we use positional notation. And that allows us to convert from any base into any base using either repeated division or positional notation. Thank you.